Hello, I'm Philip Gallia and I'm in to introduce the topic of electrical resistors, capacitors and inductors, which are the three major and basic components of electrical circuits. I will identify what these components' general purpose, basic structure and principles applied which allow these components to form their general purpose. Resistors are the most commonly used components which are designed to control the current and voltage within the circuit by consuming electrical energy. The resistor is a material with a specific resistance, ohms. The most common material used is a carbon composition, and for high current conditions, high resistive wire wrapped around ceramic core is used. To control the voltage within the circuit, resistors can be placed in a series with the supply voltage, and based on Ohm's law, the voltage within the circuit is reduced and controlled to meet design needs. To control the current within the circuit, which is recommended for specific devices, resistors and layers are placed in parallel circuits, where the voltage through each parallel circuit is equal to the supply voltage, and the resistor changes and controls the current within the parallel circuit. Also, the best way to determine the characteristics of electrical circuits, they are compared to the flow of water within a pipeline. If you place a series of objects within the water pipe, the flow of water is reduced. Parallel circuits will supply water enters the pipeline, and this supply is given to the circuit paths, which are parallel to each other, having the same supply of water, with the resistive objects changing the flow of water within the parallel paths. Capacitors are non-linear components, where the voltage and current relation is not linear, which is designed to store electrical energy and to then discharge this energy. The capacitors acquire a capacitance measured in farads. The general structure of a capacitor is an insulated material being positioned between two conductive plates, with one plate connected to the negative side of the battery source and the other to the positive. For the capacitor to store energy, a battery supply is turned on, creating a negative charge to one plate and a positive charge to the other, which creates a potential difference between the plates, which will continue to occur until the potential difference is equal to the supply voltage, charging at an exponential rate. When the capacitor is discharging, the electrons flow from the negative side of the capacitor to the positive side, discharging the stored energy, which is discharged at an exponential rate. The capacitor is generally used in the modern world on such devices such as car window wipers, which the capacitor stores the required amount of electrical energy, and this is then discharged to operate the wipers. Inductors are also non-linear components which are also designed to store electrical energy, but also control the variation in the current. The inductance is measured in henries. The general structure of an inductor is windings of an insulated wire wrapped around a cylinder core. The material of a cylinder core can either decrease or increase the inductance of the inductor due to the change in electromagnetism, which materials such as iron increases this effect, but also other variances also affect the inductance. The inductor is based on the principle of electromagnetism, as the alternating current within the wire causes an electric magnetic field in the opposite direction of the current due to Faraday's law. As the electric magnetic field opposes the current, this limits the current to the circuit to only allowing the current to flow at a certain current, reducing variation in current, which is also determined as a paddle wheel, which only allows a flow of water at a particular flow rate. Once the source is switched off, the electric magnetic field is then destructed, and the electrical energy remaining from electric magnetic field is converted and induces a current into the system, discharging its electrical energy. The charging and discharging of electrical energy of the inductor is equivalent to an exponential form. And thank you for listening.